Day, ladies and gentlemen, personalities. Today we are going to speak about geometry, but in geometry we are going to speak about congruence in triangles. So we are going to talk about congruence in triangles. So when we do talk about congruence in triangles, we're going to deal with few things. These are the objectives of our lessons. Number one, we're going to define congruence. So at the end of this session, you must know what congruence is. And then number two, you must know cases of congruence, which there are 4 in this particular case. And then number three, you need to know how congruence questions are asked. Okay, how congruence questions are asked. And then number 4, you need to know how congruence questions are answered. And then lastly, the important thing to note and pitfalls when you are working with congruence. So these are the things that you should know at the end of this session. Okay, let's start with number 1, defining congruence. Ladies and gentlemen, personalities, what is congruence? Ladies and gentlemen, personalities, congruence is nothing that fancy. It's just a fancy word that simply means exactly fit on each other. So what is going to happen here is you're going to be given a situation like this. Okay, and then they will say, show that these two triangles are congruent. Okay, you can see these triangles, they are standing in their own way. If you don't look at them properly, you can think that these angles are actually not equal in terms of size. Okay, but when you look at them closely, it turns out that they may be equal in size. Okay, so now luckily, because we can be able to move these angles, we can actually move them. Can you see? When we move them to each other, they exactly fit to each other, right? They exactly fit to each other. Now that is what congruence means. It means that they exactly fit on each other. Right. Okay, so what will happen is you will find them being orientated like this. Maybe some of them will stand like this and then some will stand like this, but you must just look at closely and follow the rules that you're supposed to follow, and then eventually you will then find out that they are congruent. So when you are saying triangles are congruent, you are actually saying that triangles, number one, they are equal in size and they are also equal in shapes. And then if you can align them to each other, they will exactly fit into each other. So that is what congruence means, right? So there are 6 things that you must choose from in order to prove congruence. Okay, those 6 things are, remember, if you are dealing with triangles here, so triangles has 3 sides and it also has 3 angles. So if you can find 3 things between sides and angles that are equal, just 3 things out of these 6 that are equal, then you would have successfully proved that 2 triangles are congruent. Okay, but you cannot just pick and turn anything. There is a certain measure that you need to follow, and then we call those measures 4 cases of congruence. Now, what are those 4 cases of congruence? 4 cases of congruence. Congruence. Okay, so what is that? The first one is side. So if you can find 3 sides that are equal, 3 corresponding sides that are equal, then you would have successfully shown that the 2 triangles are congruent. So for example, if you have these triangles like this, if you can say that, okay, let's say this one is standing like this, if you can say this one is equal to this one and this one is equal to this one and this one is equal to 3 sides that are equal, then that is sufficient to say that the 2 triangles are what? The 2 triangles are congruent. Now the second case of congruence that we're going to deal with, number 2, is side, angle, side. So you must find a side that is equal to another side of another triangle. Remember, you've got two triangles, and then you want to show that this triangle is congruent to this triangle. Okay, so if you can find that there is a side here that is equal to another side here, and then there is an angle here that is equal to another angle, and then there is another side that is equal to another side on the other side, therefore you would have successfully proved that there is congruence. So it's side, angle, side. And then the third case, but I just want to make a note with side, angle, side. This angle, it must be between, in the same way as this angle is between these two S's. Okay, this here, as it's written, it even in the sketch, it must be between the sides that are equal. Okay, when we do examples, you will see exactly what we are referring to. So it's side, 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 it's side, angle, side, and then you've got angle, angle, side, and then you've got the last one, which is number 4, which is what? Which is the right hand side. All right. So those are 4 cases of congruence. So if you are saying that there is congruence in triangles, in two triangles, then one of these 4 reasons should be proved. Okay, if you can't prove 4 of these reasons, then I do not know what is your story. I really do not know where is it that you are coming from. Okay, so now let us look at the questions so that we can see how we can go about answer questions here. All right, now another thing that I didn't say, which is important, is that to show that triangles are congruent, there is a sign that you use. It's 3 lines. Okay, 1, 2, 3. This line simply shows that, you know, we are mathematicians, so we don't write things in full, we write in short terms. So this is basically how we show in short terms that this is congruent to this one. Okay, now let's look at the first example. Okay, so they want us to show that triangle PQR is congruent to triangle KLJ. Okay, so how do we show that? Okay, let's say proof. Okay, remember we said in order to show congruence, we must show 3 things that must be equal to each other, okay, in both triangles. Okay, so how do we do this? Okay, let's look at this one and see if we can find any 3 things. Okay, now there is something that I can see here, that side PQ, right, side PQ is actually equal to side KL. Can you see 1, 2, and then there is 1, 2. Okay, so PQ is equal to what? Is equal to KL. Now, what is the reason? It's given. Okay, if there is these things written, it means that you are given that these 2 things are equal. Okay, so you just have 1 thing now. Okay, so now you are trying to get 2 more things. Okay, is there anything that you can also get? Oh, okay, I think I can see something. Can you see? PR is also equal to KG. Okay, so PR is equal to KJ. And what is the reason? I was given again. So it's given. Guys, remember, we are doing geometry. In geometry, don't just say things without saying where do you take those things from. Okay, if you do that in geometry, it's a big problem. Okay, and then what else? Okay, and then it turns out that Okay, look at QR. QR, can you see? QR is also equal to what? Is equal to LJ. So QR is equal to LJ. Okay. So somebody can say to me, why didn't you say, Mr. Makaba, why didn't you say QR is equal to JL? Why are you saying LJ? I'm saying LJ because, can you see here QR and then here there is LJ, because that is how it is aligned in the descriptions of the triangles that I was given. Okay, yes. So QR is equal to LJ, and what is that? It's given. Aha, can you see? Now I've got three things. Can you see? I've got three things. We said that in order to prove congruence, you need to have three things between these six things, which three of them are sides and then three of them are angles. If you can have any three, then you can, it's good enough to show congruence. So now we can then say that triangle what? Triangle PQR is congruent to triangle what? KLJ. Now what is the reason for that? It is side. Okay, can you see that? Wonderful. Right, now let's take the next one, and then let's see how it's gonna play itself out. Can you see this one? Aha, now they are now saying show. Okay, they are saying show that triangle ABC is congruent to triangle DEF. Okay, how can we do that? We know when we want to prove congruence, we need to show how many things? 1, 2, 3 things. Okay, 3 things. We must find any 3 things that are equal, but we've got a structure that is leading us. Here is a structure, right? That things must be in a certain way. Okay, so the earlier one, we actually used this one, SSS. Now let's look at this next one. Okay, so let's just say proof. So when I say show, guys, it's the same thing as I'm saying proof. It's just, you need to show something. You show something by proving in mathematics. So when I say show that this is equal to this, or prove that this is equal to this, that is exactly the same thing. Okay, let's see. Okay, in this case, I can see that what? That AB is equal to what? Is equal to DE. Can you see that? So AD is equal to DE. What is the reason for that? It's given. Okay, and then when I look as well, I can see there is an angle. Okay, there is an angle. I can see that there is a side. I can say side as well, but we don't have a case which is side angle. So we've got side, angle, side. So that is why we're going to follow with what? With an angle. So that is angle A. So angle A is equal to angle D. Okay, which is, and then they are both equal to 101 degrees. Okay, and then that is also given. We didn't take that from any theorem or anything. It was just given to us. Okay, and then to have something else, yes, we've got AC being equal to what? Being equal to DE. Okay, and then where do we take that from again? It is given. All right, it is given. So we can then say, okay, we've got 1, 2, 3 conditions now that we have shown to be equal. So because of that, we have hence been able to prove congruency. So we can then go ahead and say triangle ABC is congruent to triangle DEF. And then what is our reason? Our reason is is side angle side. Right? Okay, so now we have used this one. Okay, now let's look at another example and let us see what is it that we can do here. All right, we are support. Now they are saying prove. You remember earlier they said show, now they are saying prove. It's exactly the same thing, young people. So let's say proof. Okay, what can we see here? Aha, can you see? There is x here, there is also x here. Aha, so angle B, you see, I can see there's this angle equal to this angle. There is this y being equal to y. Can you see? I've got two angles. So if I have got two angles, the only case of congruence that I can use is angle side. So I'm going to start with an angle, and I'm going to start with an angle, and I'm going to look for a side. All right, so let's look for an angle. So angle B is equal to angle what? Is equal to angle D, and they are all x. Okay, and this is given. Okay, given. And then angle C is equal to angle what? Is equal to angle E, and then we are both told that these are all y. It's y, not x. I'm talking nonsense now. So that is given. Okay, right? And then now there are sides. Can you see? Now I've got sides that are equal. So I'm going to say B side BC is, sorry, no, not this side, equal to, like a normal equal to DE, and that is also what? That is also given. Now because of that, I can then say triangle ABC. I take exactly what they wrote up. The triangle ABC is congruent to triangle what? Triangle FDE. And then what is my reason? My reason is, right, so my reason is angle side. Why angle side? Because I started with an angle, and then I followed with another angle, and then I ended up with side. Okay, remember we said when we want to prove that things are congruent, we have to pick any three that we can find, and then when we find those three, we can then look at how we can present those three features in terms of the cases that are in front of us. Okay, so we have then proved this case of what? This case of congruency. Okay, now let us look at this one now. Okay, so what is happening with this one? Okay, so we've got this side being equal to this side. Okay, remember we have to prove 3, and then we've got this side being equal to this side. Can you see that? But now we have an issue. Remember, we've got angle, and then we've got this side being equal to this side. Okay, we have an issue. So this is more like side angle side, right? But now the problem is this angle is not in between these two sides that we are talking about. Okay, so if the angle is not in between these two sides, then we cannot say that those two triangles are congruent unless, and I want you to know this thing, unless that angle is a 90-degree angle. That only happens in a case where that angle is 98 degrees. So if this was another angle which is not 90 degrees, it wouldn't matter. Even if there was another angle, let's say this was 98 and then this was 98, we wouldn't have congruence here. You can explore and you can explore and see that But basically, it cannot be congruent if this angle is not 90 degrees. It can only be congruent either if the angle is between these two sides, that is case number 1, which is side angle side, or if that particular angle is what? Is exactly 90 degrees. So that is why you've got a case of congruency that we refer to as right hand side. So how do you go about showing all of these things? Okay, we can then say, okay, there is one side. Okay, in this case is, let's say GJ or GH. Let's check. Okay, no, not GH, because GH is not the same. So let's take, okay, let's say proof. Okay, so GJ is equal to what? Is equal to ML. And then how do we know that there is one here, there is one here? So it was given to us. It's given. Okay. And then secondly, now let's look at this one. Okay, let's take the other side. We've got HJ, which is equal to what? Which is equal to KL. How? And then that is given. Okay. And then we've got H being equal to what? Being equal to K. Not just being equal to anything, but being equal to 90 degrees. Now, where do we take that? That was also given. Okay. So you've got two sides and an angle. So basically, you've got triangle GHJ, which is congruent to triangle. So triangle what? Triangle MKL. Now, what is the reason of this congruence? Is RH is right hand side. You've got one of the angles being what? Being a 90 degree angle. That's what causes congruency. All right. Wonderful. Now, ladies and gentlemen, personalities, I want to alert you to one of the very important things that you should be aware of whenever you are dealing with problem in congruency or in congruence, when you're dealing with congruent triangle. All right. So one of the things that confuses people, and guys, I want you to be very aware of how questions are asked in mathematics. So what happens in mathematics is you will be given a concept and then you'll be asked to prove those concepts in hidden places. Okay, so that is why, for example, in congruency, you'll be given triangles that are oriented differently, and then you just have to zoom in closely and use the rules that you are given to show that these two triangles are congruent. Okay, I just want you to notice that in most of the questions that we've dealt with, the reasons has always been given. All right. So, ladies and gentlemen, one of the important things that you should know, which is very, very important, is that it is not always the case that you will always be given. That's, for example, this side is equal to this side. Okay. Now, we're very lucky in this particular instance that things were given, and it does happen in papers that things are given, but sometimes it is not the case. You will have to use other mathematical rules in order to show that some things are given. Maybe you'll be given some other things and some other things won't be given. You must use other mathematical rules. So let me just give you one of the examples where that will be the case. So let's look at this one. So basically what you are trying to show here is that triangle AEC is congruent to triangle BED. So where is AEC? AEC. You want to show that it is congruent to triangle what? B, which is BE what? D. Okay. Now, let's go ahead and prove. We know that to prove congruence, we need to show how many things? 3 things. Okay, so here we have a proof. Okay, so we can see there's one line here, one line here. We can see that AE, right, is equal to what? Is equal to BE. What is the reason for that? Luckily this time around we are given. Okay, can you see? Now we've got 2 sides here, because we can see already that this one is equal to this one. Okay, but now when we've got 2 sides, the only thing that we have is side angle side. We don't have side angle. So that means the next one that we need to prove is the angle. Now I want you to look at these 2 angles. Can you see this angle and this angle? Can you see? Aha. So this angle is equal to this angle. Now how do you know that this angle is equal to this angle is equal to this angle? Because they are vertically opposite angles. All right. So now how do they, now can you call this angle E? Now the thing is, when you say this angle is E, now what is it that you are going to call this one? Okay, so now I'm then going to introduce you to something that some of you already know, the way of naming an angle so that you can be able to differentiate it with another angle that takes from the same point. Because can you see all of these angles are coming from the same point? Okay, so how do you mention this angle differently, and this angle and this angle, this angle? So but we're going to deal with this angle and this angle. So when you name an angle, you name it in terms of where it comes from and where is the apex and where it ends. So for example, this one comes from A. Can you see it's A, and then the apex is in E, and then where it ends is in C. So you then say triangle A, E, but now because apex is in E, then you must put a hat in E. Angle AEC. Can you see that? Now E is equal to triangle what? Triangle DE, but because the apex is in E, so it's DEB. Can you see that? Now, how do you know that this angle is equal to this angle? It's vertically opposite angle. Vert for vertically, op for opposite angle, equal. Okay, this time round it is not given, but we got it from one of the rules. Do you understand? Okay, and then lastly the other one we are given. So triangle EC, side EC is equal to, sorry, line EC is equal to line DE, and then what is the reason? It is given. Okay, so because of that, triangle AC is congruent to triangle what? So triangle BED, what is the reason? It's side angle side. All right, did you see that? Okay, ladies and gentlemen, personalities, let us then deal with the last case. Okay, now I want you to notice, okay, you've got, can you see you've got this side being equal to this side, okay, and then you've got this side being equal to this side. Now I want you to look at these two things properly. You've got this triangle being equal to this triangle. When you look at this triangle, it visibly looks bigger than this triangle. Okay, so some of you may remember when we say congruent, it means exactly the same. That means same size and same shape. And then another thing that it means is that you can literally fit this triangle into this triangle. Okay, so but when you look at these two, it turns out that we can actually not fit this one into this one because this one looks bigger than this one. Okay, so you will sort of come across these cases when you are dealing with congruence. Okay, now I want you to be very careful of this. Okay, here explicitly you are told that this side is equal to this side. Now this side does not look like it's equal to this side, but you are told that it's equal to. Now what is it that causes sides to be declared as equal whereas they are not equal? It's because there may be some typing error when you are busy writing this shape. They can also be what? They can also be the fact that, remember, there's something that they always say in papers, that shapes are not written to scale. So that is why this one can look bigger than this one. But if they say this one is equal to this one, it does not matter how it looks. But what it really matters is what they are saying. So be very careful of that. And please do not be confused with that. So in terms of what we are given and what is written, so how can we show that triangle GHI is congruent to triangle GLI? Let's prove. Okay, so we can all see that GH is same as GL. GH is equal to GL. Can you see that? Now I have to know that it's given. Okay, it's given. Can you see that? And then you can see that HI is same as LI. Not the same. Why am I saying the same? It's equal to, because when you are saying same can be a lot of things. I can say you are the same as me because we are the same age. I can also say you are the same as me because we are both coming from the same area. So when you say the same, you sort of, there's a lot of things that could be involved. But when you are saying equal to, it's something different, because we are saying these things are equivalent in value. Okay, so don't say same. Please don't be like me. Don't say same. You must say equal to. Right. So in this case, HI is equal to what? Is equal to what? Is equal to LI. Okay, now where do we take that from? It's given. Okay, now I want you to look at these two triangles, this triangle and this triangle. They are sharing a point. Now which point is that? Is GH. So here what you're going to say is you're going to say GH. So not GH, it's GI. GI is common. Okay, so that means basically GI is equal to GI, but basically GI is common. That's how we phrase it. And then so because of that, then what we say, and but remember, GI is what? GI is a side. So you've got a side and a side and a side. So then here you then get triangle GHI being congruent to triangle GLI. Now what is the reason? The reason is side, side, side. All right, which is this one. Okay, so now let's go back to our objectives and see if we're able to meet our objectives. Were we able to define congruence? Yes, we were able to define congruence. That when we're saying congruent, we simply means that the two shapes, the two triangles can fit into each other. And then did we spoke about it? Do you now know the cases of congruence? 4 of them, yes, you do know. You know that there is side, side, side. You know there's side, angle, side, and then this angle must be in the middle of these two sides that are these corresponding sides that are equal. And then you've got angle, angle, side, and then you've got a last case which is right and side. Okay, and then number 3, how congruence questions are asked. You did see that sometimes they say show, sometimes they say prove, but that means one and the same thing. And then you knew that when you are showing sides between 3 things, whether sides or angles, sometimes you can be given, but sometimes you can use other mathematical or geometry rule to show that this feature is equal to this feature. So that is how questions are asked. And then you did see how we get to answer those questions. Né? And then you didn't, and then were you able to look at important things to note and pitfalls that you have in congruence. Yes, we're able to look at pitfalls and things to note. So for example, we know that sometimes, in most cases, if not all, you will always be given shapes that are orientated differently. So in that way, if you don't look at them properly, you can think that they are not equal in shapes and size, but when you look at them closely, then you can be able to see. So in that particular case, we did mention that what you have to do is you have to look at what you have to look at the features that you are given and how you can align them to the 4 cases of congruence. Ladies and gentlemen, this is congruency. This is for grade 9 people. This is for grade 9, but also in grade 10, 11, and 12, you are going to use congruence in order to prove something else other than sometimes it will be congruence itself directly, sometimes it will be something else, but you will see that directly. So it is important for anyone who's doing grade 9, even grade 8 sometimes, grade 8, grade 9, grade 10, grade 11, and even in grade 12, there will be some other thing. Actually, there is a case where congruence is asked directly, or sometimes it is asked indirectly. So you must know what congruence is and how to prove it. So ladies and gentlemen, personalities, this is Mkondes Macaba from Tembela Maths Club, a club that helps learners to understand mathematics. And thank you very much for tuning in, and have a lovely day, and goodbye.